Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Selamat datang ke Shah Nun Channel, saluran pendidikan anda. Jadi kita teruskan pelajaran kita iaitu Introduction to Organic Chemistry di bawah subtopik Isomerism. Jadi tanpa melengahkan masa, mari kita mulai. Okey, chapter yang ke-11 iaitu Introduction to Organic Chemistry 11.4 Isomerism. Our objective, number one, define isomerism, and then explain constitutional isomerism, change isomers, positional isomers, and functional group isomers. Actually, isomerism can be divided into two. Number one, we call it structural or constitutional isomerism, and then stereoisomerism. And constitutional isomerism can be further divided into three: chain isomerism, positional isomerism, and functional group isomerism. For stereoisomerism, can be further divided into two. We call it diastromers and enantiomers. Okay, and diastromers can be further divided into cis-strand isomerism and other diastromers. In our syllabus, for stereoisomerism, we will focus on diastromers, cis-strand isomerism, and enantiomers only. Okay. Okay. Next, we go to the what is isomers. Okay, isomer is the existence of different compound with the same molecular formula but different structural formula. Two type of isomerism, as I mentioned before: constitutional and constitutional is isomer with the same molecular formula but differ in order of attachment of atoms. And stereoisomers, isomer with the same molecular formula but different arrangement in atom in space. Okay, constitutional ataupun structural isomerism. Nama lama ialah structural isomers. Yang diguna pakai sekarang ialah constitutional. Alright. Isomerism resulting from different way of attachment of atom. Three types. Number one is chain isomerism, positional and functional group isomerism. Chain isomerism, the isomer differ in the structure of the carbon change or differ in the length of straight change or branches. They possess the same functional group and belong to the same homologous series. For example, C5H12. C5H12 is molecular formula. Actually, it has three isomers. Number one is CH3, CH2, 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 and CH3. This is we call it straight change alkane. All right. And the second one is alkane with one branch. Okay. The difference is this straight change only has 4 carbon: 1, 2, 3, 4. This one 1, 2, 3, 4, 5, and the other one is become a branch. The third one 1, 2, 3, the straight change, or we call it backbone. The backbone of the molecule is only 3 carbon, and we have 2 branch here. Okay, so this is what we call change isomerism. And for the positional isomerism, this isomer have a functional group or substituent group in different position. For example, we have C3H7Cl. Okay, this is molecular formula C3H7Cl, and then we write the uh, structural formula. In this case, we use condensed structure, right? CH3, CH2, CH2, Cl. In this case, Cl in carbon number one. Let's say this is carbon number one. Where is my pen? Okay, let's say this is carbon number one, carbon number two, and carbon number three. In this case, chlorine attached to the carbon number one. And for the second structure here, now the chlorine at carbon number two. This is carbon number one, carbon number two, and carbon number three. So the position of functional group, chlorine is a functional group. We call it halogen, right? The halogen here, the functional group of halogen here, or chlorine attached to carbon number one, and this one at carbon number two. That's why we call it positional. The position of functional group at different carbon. Example 2, C4H8. Okay, this is alkene. For this example, the carbon-carbon double bond at carbon number 1, in between carbon number 1 and carbon number 2. And for the second example, the carbon-carbon double bond at carbon number 2 and carbon number 3. That's why we call it positional isomerism. Okay. And the third example is C8H10. Okay, this one we have benzene here, benzene ring, and here this is what we call substituent. Okay, substituent. Okay, the substituent at carbon number 1 and at carbon number 2. And for the second structure, the substituent at carbon number 1 and carbon number 3. And for the third structure, the substituent at carbon number 1 and carbon number 4. This is example of positional isomerism. Okay, and the last one is functional isomerism. Isomers have different functional group and belong to different homologous series with the same general formula. For the general formula and classes of compound. In case of functional group isomerism, um, the classes of alcohol we have the classes of compound we have um, in this case alcohol and ether, because alcohol and ether have same general formula, which is CnH2n plus 2 NO, oxygen. Okay, they belong to the same general formula. That's why alcohol and ether fall in functional group isomerism. Okay, the second one is aldehyde and ether. Okay, because aldehyde and ether also uh, belong to the same general formula. And carboxylic acid and ester. And the last one is alkene and cycloalkane. Okay, only this uh, only this 1, 2, 3, 4, 5, 6, 7, 8. Only these 8 classes of compound has the what we call functional group isomerism. Okay, because they have the same general formula but different functional group. For example, C2H6O. So this is ethanol, CH3, CH2OH, and for the ether is CH3OCH3. Okay, this is name of the ether, dimethyl ether, and this name of the alcohol, ethanol. Okay, they belong to the same general formula. And then C3H6O, this one is propanone and propanol, propanal. Even though even though they have the same functional group, we call it carbonyl, right? We call it carbonyl, but this one is different classes of homologous series. Okay, but this one no problem because different in functional group and also different in homologous series. This one they belong to the same um, functional group, but they still in functional group isomers. This one is carboxylic acid and ester, right? Carboxylic acid. This is functional group of carboxylic acid. We call it carboxyl, and for ester we call it carboalkoxy, right? Different class of homologous series and also different in functional group. Okay, now we look at the exercise. Determine whether the pairs are same compound, different compound, or structural isomers. Okay, for this example, look at this example. Okay, I change the color. Okay, if you look at this two example, carbon attached to 2H and 2 chlorine. This one also carbon 2H and 2 chlorine. So this is same compound. Okay, this is same compound because we cannot see any differences between these two compound. For B, okay, okay, look this different, but now we want to test whether this is same compound, different compound, or structural isomers. So in this case, if we count the number of carbon 1, 2, 3, 1 bromine and 1 chlorine, and 6 hydrogen. This one also 1, 2, 3, 3 carbon, 6 hydrogen, 1 bromine and 1 chlorine. So same molecular formula. Okay. Now I want to give the number for this carbon. This is number 1, number 2, and number 3. So when I write like this, bromine at carbon number 1, chlorine at carbon number 3. Now we go to here. So this carbon is number 1, number 2, number 3. Bromine also attached to the carbon number 1. Chlorine also attached to the carbon number 3. So same compound. Here also same compound. Okay, the second one, the question number C. So how many carbon? 1, 2, 3. Okay, 3 carbon. Here, 1, 1, 2, 3. Also 3 carbon. But I can spot the difference here. 1 OH and 2 OH. So clearly that this is different compound. Different compound. Okay, because this is alcohol, this is diol. Different compound. And then question D. Okay, how many carbon? 1, 2, 3, 4. 1, 2, 3, 4. And how many chlorine? 1, 2. Okay. Now we test. I want to number this carbon from here. 1, 2, 3, 4. 4. So here also 1, 2, 3, 4. Okay. The first carbon, this chlorine attached to carbon number 1. This chlorine also attached to carbon number 1. Okay, look at this carbon. Look at this chlorine. This chlorine actually attached to carbon number 4. How do I know? because this carbon only has two H. So this chlorine must attach to carbon number 4. Okay, look at here. This chlorine also attached to carbon number 4 because this is CH2. So actually this is same compound also. Okay, the next exercise. There are 7 structural isomers of C4H10O. Draw a pair of change, positional and functional group isomers. Okay. Now, uh, 7 structural isomers. Okay. But in this question, we have to draw only a pair of change, positional and functional group. Before this, we look at this C4H10O. So CnH2NO. So this must be alcohol and ether. Okay, ether is the opposite of uh, alcohol, or we call it what we call it functional group isomers for alcohol is ether, right? Okay, now I want to there are 7, but we don't have to draw all the 7. What we have to draw is only a pair of them. The first one is, of course, isomers. Change isomers. So the first one, I just draw a linear isomers of alcohol. So easy for me. One, two, three, four, and then OH. So I just want to check whether the H is 10, 3, 5, 7, 9, 10. Okay, 1 O. And for the change isomers for this, now I just make it shorter, become 3 carbon. 1. Okay, for the second carbon, I want to write the branch 1, 2, 3, and then it's become 4, and then OH. Okay, 3, 6, 7, 8, 9, 10. Okay, this is change isomer. Now I want to draw positional isomers. Positional, positional isomers. For positional isomers, I can draw this one again, no problem, because the main thing is we can show the positional isomers CH2, CH2, and OH. Okay, for the positional isomer, I want to draw um, still 4 carbon as a backbone, but the OH here I will replace 2 here. Okay, CH3, CH2. Okay, the carbon number 3, I want to put OH, but now the CH2 becomes CH because I want to put OH here, and the last one should be CH3. Okay, 3, 5, 6, 7, 8, 9, 10. This is positional isomer. And the last one is functional group isomers. Functional group isomers. Okay, don't look at my writing. Okay, I just write whatever alcohol that I need, and I choose the straight one, and then I choose ether. Over here, ether is like this, and then uh, make it 4 carbon. Okay, this is the functional group isomers 1, 2, 3, 4 OH. The functional group is hydroxyl, and this one is alkoxy. Okay, and then the last one. Okay, last exercise for today. Draw all the structural formula for the molecule C5H12O and classify them as change, positional, and functional group. This one is quite tough because we have to draw all and then we classify them. Okay, C5H12, so CN, H2N, so 12. This is also alcohol. This is also alcohol with 5 carbon. Wow. Okay, for this exercise, I just draw the skeletal one, not skeletal, but I don't draw the H. Okay, 1, 2, 3, 4, 5. I don't draw the H because if I draw the H, then it will take a long time to finish this video. 1, 2, 3, 4, 5. Okay, and then I still maintain the 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. But I change the OH, and then I still want to maintain the 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. The OH is here. Okay, this is positional actually. At carbon number 1, this is at carbon number 2, and this is at carbon number 3. Okay, I cannot draw like this because if I change the OH to here, then it's become to the carbon number 2. Okay, so 3. Now I want to make a branch with the CH. So now it's become 4 OH. Okay, and carbon here 1. Okay, now I still want to maintain 4, and the branch now is here. Okay, now I have 1, 2, 3, 4, 5. Okay, and I can draw for alcohol the last one of alcohol, so should be like this. Okay, 1, 2, 3, 4. Okay, this is the maybe the last one. Okay, yes, this is the last one of alcohol. 1, 2, 3, 4, 5, 6. And then structural isomer. No, the functional group isomer for alcohol is ether. Okay, this is number 1. 1, 2, 3, 4, 5. I just want to maintain 5, but the O and carbon number 2 like this. Okay, okay, this is 2, and then I want to make it branch. 1, 2, 3, 4. Okay, O here, and then it's become 4 carbon. 1, 2, 3, 4. The first one is here, and then maintain 4 like this. 1, 2, 3, 4. Now the branch is here. Okay, here. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, maybe the last one is this one. This one I want to write this one, and the branch is here. Okay, like this. O, and then here and here. Okay, so we have 11 actually isomers of this molecule. Okay, and then classify them as change position. Okay, to classify them, we have to give them number. For example, like this: 1, 2, 3, 4, 5, and so on. And then we just write the change isomer. Change isomer is number 1 and uh, number 4, something like that. Okay. because the change is we maintain the backbone, 5 carbon, and versus with 4 carbon with branch. Okay, so 1 and 5, 1 and 6, and so on, something like that. And also this one and this one. Okay, we just can rewrite. We just arrange them. Okay, I think this is first isomers, and we have the next video. The next video we call it. Okay, itu saja untuk kali ini, untuk first round untuk isomerism. Kita ada second round untuk isomerism. Jadi jumpa lagi di lain masa.